Hello and happy Easter. Today I'm going to be doing just a little bit of side tasks on my motor control board, which I'm using to drive two motors currently. One of the things that I have to fix quite urgently right now is the way that I'm calculating the microseconds, or rather not the way I'm calculating it, but actually just double checking that if the microsecond counter overflows, I don't want any bad thing to happen. So I'm going to be looking where I'm using the microsecond counter, and I'm going to be setting it on purpose somewhere close to the overflow value, so that I get it to overflow much quicker, and we'll see what happens. Because I suspect that there is some issue with this in my CanOpen code, which disturbs the communication if the counter overflows. So I'm going to force it to overflow now, and we'll see if the board is still working as it should. So I'm going to power on the master board, and I also have the slave board, which is responsible for the motors. And the master and slave, they communicate with each other over CAN bus. So when the boards are communicating, the LEDs are going to be lit. And if there is a communication error, then the master board is going to go into wait state, where it will wait for the slave board to come back online. And I think there is something that's related to the microsecond counter, which is kind of screwing that up if the microsecond counter overflows. Now I can print the microsecond counter value. If I go to, let's see, I'm supposed to be able to do this. I think the reception is screwed up again. There's a cable going for the Rex line. Let's see. Can I get the Rex? Yes, that's working. There's a little glitch in the Rex line. So I can do like this. If I print out the data, I can see the microsecond counter counting, and it will overflow when it gets to half of the uint32. It's a uint32 number, and it's not designed to be used for long delays. It's just designed to be used for kind of checking if a timeout has occurred. If you check for the timeout at every frame. So it's not for timeouts that should put the CPU into sleep mode. It's more for things like checking some timeout over multiple frames. So for example, if we're running the control loop, we can use this to dim LEDs, because that's a very slow task, and it's going to run anyway. The control loop is going to run anyway, so it makes kind of sense to just check how long time has passed since the last update, for example, to the LEDs. When checking such small delays, we can just do a subtraction of two uint32s, and we can check if that ends up. If we then cast it to assigned int32, we actually get the difference between the two values. And even if they overflow, the difference is still going to be correct. So this is also how the tiling code in Linux works. And what they do in Linux is that they actually set this the value of this microsecond counter to a value that is almost like very close to the overflow, so that it overflows shortly after boot up. And if there is any problems related to it overflowing, then those problems will be apparent shortly after boot up, instead of happening a long time after the system is started. So as you can see, it still hasn't overflowed. It's going to overflow at, I think, something like 21. So 21. Let's see, 2 point. Yeah, it's going to be like 2.1 billion microseconds. So it's going to continue counting, and while it's counting, I will go to. Let's see. I will go to the initialization code, and I will make sure that this counter is actually set to some value that is higher than 0. Or we can set it to a negative value. That works too. So let's see. Now it's going to overflow. Then it's going to go to negative number. Let's see. Once it goes to negative number, what's going to happen? Let's have a look at this. So let's have a look at the board. What's going to happen? I think the LEDs are going to turn off, because the board is going to go to the wait state. We'll see. Maybe it will work. Maybe it's something else that's causing it to go to wait state, to lose the communication link. Let's see. let's see, that's 200. Oh, that's 246 million. So it's going to take a while. It's much better if I just set this value to something else. I have this code in the timestamp, I think. Timestamp. This is platform dependent. So for this STM32, I read out the microsecond counter like this. This is a little bit involved process because we have to check if the uptime has been updated, because it's updated asynchronously, and it's updated in application tick hook, which is called by the sysdig interrupt. So if some code calls this, and let's see what will happen here. So yeah, so what will happen is that sysdig will overflow, and if we get this sysdig uptime, and then we get the count, and if it overflows between these two lines, then we're going to get the wrong count. So we check if we simply check if it has overflown. If there was an overflow, then we have to retry again. And on the second try, we're going to succeed because it's not going to overflow very quickly. This will give the microsecond counter that will count up, and then it will overflow at the half of uint 32. If we consider it being assigned int, which is what I'm printing in the console right now. But what we could do is actually to initialize this sysdig count, let's say sysdig uptime, to some value other than 0. So we can set here like, we can set a value uint 32 minus, and this will count 1,000 counts per second. So let's set this to minus 10,000. And I will actually recompile this, and let's see. Actually, I'm going to set this to 20 because I want to have some time to start the board and bring it into operational state. So, building and flashing. And ready. And now, let's see, FB data, and then let's see here. Oh, actually, this was wrong. It needs to be. It actually needs to be set to int. Let's see. Oh, there we go. Haha. Now it happened. So now it went to the default state. So it didn't even take setting this counter to half of int, so it overflows in the middle. So something is going on here with the way this this microsecond counter is used. So I'm going to check where I'm using this microsecond counter, and I'm pretty sure I'm using it in the CanOpen code, which could be the problem. But I'm going to just do a quick grep here, micros, and let's search in everything. So we have a lot of this code is used in the main firmware. Let's see. This is, for example, simple function that does the blinking. It just it has a blink delay for set to 100 microseconds. Or 100 milliseconds, so it blinks 10 times a second. Let's see, actually here I'm waiting. Let's see. And this is actually the way that I'm using for checking if the timeout has expired. But this is not something that would cause this type of problem where the board goes to default state. So I'm going to check further and see if I can find where it could go to default state. Let's see. So pressed time. This is something I want to check as well to make sure that. Let's see. think the function that checks whether the time is after, I think it's correct. I think there is nothing that could, at least I cannot see anything obvious that can go wrong here. But the question is if I'm checking it in some wrong way somewhere. So that's what I want to check. Let's see, so time, if micros after that, no. Let's see. So this could actually switch mode, but this is basically for control mode. So this will not go into default state. But I think there could be something that could go to default state. Let's see. This could definitely go to default state. So I wonder if this is what's going on. Let's see. I'm going to try this. And then if this is actually causing it to go to default state, then I can debug further. Let's see. So slave timed out. Yeah. So this is bringing it into default state. And it's actually unsurprising because this is actually not a time stamp. This is supposed to be a timestamp T. Which could cause the problem, but I think that it's basically, unsigned long would basically be a 32-bit integer, but it could actually have some implication when this one is of uint32 instead of unsigned long. But I'm going to check a bit farther here. So if I go back to this, and so because this is a macro, we should maybe actually cast this to unsigned long, so that compiler doesn't decide to do something else. This is supposed to be B, A. So if A is after B, then this will be, or actually no, this was correct because this one is using more or equal 0. So if A minus B is more or equal 0. Could this really make a difference? Oh, I forgot that. I have to turn off the motors if ST-Link is going to be able to read the firmware. Because it has to read the firmware when it's going to verify it. And if the motors are running, ST-Link fails. Turn on the motors again and enter into operational state. And let's see. Actually, I want to add something here. Name. Yeah, it timed out anyway. So why is it timing out? What is happening here? So T is going to be micros. And then if, let's see. I'm going to print this out. And then timeout minus T. Working too long. Okay. And also I'm going to add some code to the inputs. Supposed to be unsigned as well. Okay. Cool. Ah, of course. Always remember the parentheses. Now it's timing out all the time. Because, which is quite obvious because the motors are turned off. Let's see. So turn it on again and going into operational. Let's see. So it's counting and it's gonna overflow pretty soon. So what happened here? Let's see. So I think that slave timeout, how much is that? So this explains why it's 1 million. But then for some reason, it actually ends up being 1,352,000 at that point. So I want to make sure that this code actually works. Let's see. So why is this timing out? Why is this getting some weird result right after the overflow? Could it have something to do with the way this one is calculating things? I'm gonna check some information about the Linux time after. So Linux uses this for the Jiffy counter, whereas I'm using this for the microsecond counter. Wait a minute, so does this actually cast this too long? So time before am I doing this wrong? Let's see. Header. So Should I maybe cast this to long instead? And maybe then I don't need to convert it either. Yeah. Okay, same problem, doesn't really matter. So what is the issue? So for some reason we end up with timeout that is behind. Or maybe, actually, maybe the problem is actually related to the fact that all of the bits are not actually being set. Interesting. Let's see. Data missing. Okay, let's see. Turning on that one. Yeah. So I'm probably missing something here. So valid bits and okay. actually, I'm not locking it properly. So this could actually be screwing things up royally for the function that's doing this. Let's see. Let's get this data out. Yeah, I'll actually lock the whole section here. Actually, no, I shouldn't be locking the whole section, because I should be locking only the data. It does take a little bit more work, but just locking the data is the proper way to go. So uint 32 bits equals, let's see. Could actually do it like this. I'll unlock it before calling the function there, so I'll set this data, then unlock it, configure slave, and return. And then, let's see. And unlock on the slave. So, let's see if this works better. So the can open messages, when they were arriving, the code that was responsible for handling them was writing the variable. Let's see, data missing, valid bits 0, because the motor is turned off. And why is it 0? Now, okay. Let's reboot this and try again. So it's starting up. Operational, and actually, I think I know what the problem is. I think this this variable is actually never initialized. So this is actually the problem. So last valid needs to be set in the initialization to current microseconds. Let's see. This is getting quite messy. Okay, if this has timed out, then I set this to current time, which is correct. This is really messy. let's see if it fixes the problem if I just initialize this correctly. So let's see, where am I initializing a slave structure? Could put it here. I assume that it's valid. Although it should be, let's see. It should still work though. I would expect it to work. Okay. Initialized. Now let's see here. Yep. So now it's working. So the lesson learned here is that always initialize the timeouts to current time before using them. And this actually needs to be initialized to micros before it reaches before micros reaches sort of the half mark. So I think I need to refactor this code to make sure that this is not going to be necessary. So it wasn't a problem with the way I calculate what the time is after another time. It was rather a logical fault. When this was being called at when last valid was 0, this actually did not work properly, because this would end up being 1 million, and then if t is higher than half of signed integer, then this will be, then this I think will actually end up being a positive number. So it will not be less than 0. So then it will not time out. Alright. This is total crap. I need to refactor this function. Yeah. And that's it for this video. Happy Easter!